Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into something you can actually understand.
Today, we're looking at a paper that sounds like it's straight out of science fiction. Imagine if an AI could read a patient's medical chart and predict what might happen to them next, helping doctors stay one step ahead.
It's not science fiction anymore. The paper is called Training Large Language Models to Predict Clinical Events, and it tackles a huge challenge in medicine, making sense of all the notes that doctors and nurses write.
Right. When you think about a patient's record, you might think of neat, tidy numbers. Blood pressure, temperature, lab results. That's called structured data, and computers are great at analyzing it.
But so much of the crucial information is in what's called unstructured data. These are the free text notes, where a doctor writes something like, "Patient seems more fatigued today and is complaining of shortness of breath." That context is incredibly valuable, but it's messy and hard for a computer to process.
Exactly. It's easy for a computer to see a number go up, but it's much harder for it to understand the nuance of a sentence. This paper presents a really clever way to teach an AI to read and understand the entire story of a patient's hospital stay, notes and all.
They call their method foresight learning, and the best way to think about it is like this. Imagine you're reading a mystery novel. You stop halfway through and you try to predict who the culprit is based on everything you've read so far.
And then you finish the book to see if you were right.
Precisely. That's what they did with patient records. First, they took all the clinical notes for a single hospital admission and arranged them in chronological order. This creates the patient's story, or what they call a trajectory.
Then comes the fun part. They pick a random point in that story, let's say 48 hours after the patient was admitted. They feed all the notes created up to that point into a separate AI.
And they basically ask that AI, okay, given everything you've just read, what are some plausible things that might happen next? The AI generates a bunch of questions like, will this patient need a blood transfusion? Or will the patient require a ventilator?
And this is the crucial step. To find the answers, they just look at the rest of the patient's record, the notes from after the 48-hour mark. Did the patient end up needing a ventilator? Yes or no? That becomes the correct answer, or the label for that question.
After repeating this process thousands of times, they've built a massive dataset of training examples. Each example consists of a partial patient story, a question about the future, and the real-world answer.
This is the perfect food for a large language model, or LLM, the same kind of technology behind tools like ChatGPT. They took a powerful open-source LLM and started training it on this dataset.
And they used a really efficient technique to do it. Instead of retraining the entire massive AI from scratch, which is incredibly time-consuming and expensive, they used something called LoRA, which stands for low-rank adaptation.
You can think of LoRA as adding a small, highly specialized expert module onto the existing AI. You're not trying to reteach it everything. You're just teaching this new module to be an expert in predicting clinical events. It's much faster and more targeted.
So the big question is, did it work? It absolutely did. The newly trained model was significantly better at making predictions than the original off-the-shelf model. In fact, in their tests, it even slightly outperformed GPT-5 on this specific task.
One of the most impressive results they shared is a metric called top 10% lift.
It sounds technical, but the idea is simple and powerful.
Let's break it down. Imagine the AI analyzes 100 patients and flags the 10 it thinks are at highest risk for a negative event.
What the study found was that in that hand-picked group of 10, the negative event actually happened about 3 times more often than the average patient.
That's huge for doctors. It means the AI is really good at separating the signal from the noise and pointing clinicians toward the patients who might need the most attention. It helps them prioritize.
And it gets even better. The model doesn't just spit out a number, like a 70% chance of needing dialysis. It can also provide its reasoning, pointing to specific evidence in the patient's notes that led to its prediction.
They even tested the quality of this reasoning. They used another AI as an impartial judge to compare the explanations from their trained model against the original base model. Their trained model won 84% of the time. Its reasoning was judged to be more detailed, better grounded in the patient's history, and ultimately more clinically useful.
So what's the big takeaway here? It's not just about this one model. The most important contribution is the framework itself, the recipe for turning messy clinical notes into high-quality training data.
Right. Every hospital in the world is sitting on mountains of this data. It's a record of the past. This paper shows how we can use that record to build tools that help us see into the future, even if it's just a little bit.
It's not about replacing doctors with AI, but about giving them an incredibly smart assistant that can read a patient's entire story in seconds and flag potential risks that a busy human might miss. It's a way of turning the data we already have into life-saving insights.
A fantastic paper showing how we can unlock the stories hidden in clinical data to anticipate what patients need next.
That's all for this episode of Daily Papers. Join us next time as we dive into another piece of groundbreaking research.